Hi, JB Reed, GitLab Customer Success, coming to you on a Friday afternoon with an interesting exploration of a customer feature request. So my team is working with a customer who was looking for more granular control over their scan result policies or their merge request approval policies, as they're now called. This is a fairly new customer to Ultimate, and they're looking to bolster their security posture by implementing policies that will enforce mandatory scans for things like dependency scanning and other capabilities across their organization. But as they kind of warm up to this implementation and build the muscles they need to have a stronger SecOps sort of discipline, one of the things, and really get used to a new way of working in GitLab's DevSecOps platform paradigm, one of the things they'd asked about was the ability to customize the identifiers or the vulnerabilities used that would trigger a merge request approval policy. So effectively, what they were looking for was to say, hey, listen, we would like to start blocking projects or teams when critical vulnerabilities come up. But right now, we probably have a lot of critical vulns. We have a limited number of people who can triage and approve that. So we would rather take kind of a permissive approach initially and let the pace of work continue fairly unabated, but bring some visibility to those scan results. And as they build kind of a list of these are the vulnerabilities we feel must block progress and should not, allow a team to move forward with a merge to production, let's say, we want to be able to kind of custom deny list a list of CVEs. There's an issue that speaks to this that I will link that talks a bit about this, right? That this has a couple of mock-ups and envisions how you might do this from a policy editor point of view. But what we're hearing from product right now is that this is probably 12 months out. We're looking at accelerating it, but that's kind of the realistic estimate that we were handed today. What could we do in the interim? How could we potentially offer something of a script-based workaround or a faster path to an outcome here that doesn't involve native product updates that are a little heavier here? So I went on a little bit of an exploration here, and I'll walk you through what I've got today. Before we do that, I think it behooves us to just have a baseline level of understanding of how dependency scanning works today. So I've got here just a basic Hello World Node.js Express project where I've pulled in my package file here a couple of known, like older versions of libraries or dependencies that have known critical vulnerabilities published against them in NIST's CVE database. And I have run a pipeline here. This pipeline was this is just an auto DevOps pipeline. The project has no GitLab CI YAML. The eagle-eyed watching my screen might have noticed that already. But we are invoking dependency scanning here via a custom code block security policy or a scan execution policy. And what I'll show off here specifically is to say, actually, before we talk about that, let's just talk about how dependency scanning works, because I think that's an important sort of baseline level of knowledge. Once that dependency scanner runs, it publishes a report artifact, which is just a special type of pipeline artifact. And it includes a JSON file called GL dependency scanning report that, as the name might imply, is the list of findings from our Gymnasium scanner that includes information like severity and identifiers like a CVE and a CVSS vector in some cases. So the thinking here is, how can I customize that file to effect a change in severity? So today, if we go to edit a policy, and I'll show that briefly here, if I wanted to introduce an MR approval policy blocking the approval, like requiring an approval or blocking the progress of a merge request upon dependency scanning findings, I could say that, against, let's say, all branches or all default branches, and maybe just for critical severity levels. That would help, kind of cut down the noise a little bit and give either, anointed approvers within project teams or say my security operations folks, a smaller body of work and a backlog to triage. But what if I know I have a lot of critical vulns, and I just don't have the firepower to triage all those. Um, Today we don't have kind of a customized per identifier way to be more granular here. So what I had envisioned here in that little Go module I've written to try and get this done is what I've called my dependency scanning re-rating script. And effectively, what this script does is you can instantiate this after the Gymnasium analyzer publishes its JSON file, but before the job is finished. So as an after script, it loads in that dependency scanning report we talked about, loops through it, and says, "Hey, is this a critical vulnerability? And if so, I will re-rate it down to high in this case." And you can envision how you might customize this or modify that to suit your needs. And then we've got a deny list that you can actually manage via an environment variable, but it's just in this case, a comma delimited array of CVEs that I want to say, no, I'm actually going to put this on a deny list. I agree that this should be critical, and I would like for this to trigger that policy we talked about in the editor today. So what I've got in this public demo group that will also be linked is a policy, a scan execution policy that utilizes some really cool new functionality we recently released, where you can automatically use the action type of insert a CI code block. So kind of similar to what we had with compliance pipelines. You can write custom YAML here, and in this case, I've stipulated my deny list. So these are the CVEs that I want to explicitly avoid derating, and I want to leave them at critical. And then I'm invoking dependency scanning, and I'm overloading the dependency scanning job definition here with an after script that calls that module I talked about. So after dependency scanning, Gymnasia runs, publishes that JSON file to the working directory. That little Go module will then, load it up, iterate through it, and kind of transform some of those findings in a way to derate those vulnerabilities and potentially allow them to avoid being blocked by that MR approval policy. So I'll do my best to show this in action without boring everybody with a bunch of JSON. But here's, for that same kind of vulnerable Hello World project, a recent pipeline. And within that pipeline, the Gymnasium dependency scanning job here cranks out its JSON file, and then this little Go module, this little script gets invoked, and it starts looping through and it says, okay, here's a vulnerability with this UUID or identifier. It's a critical severity vulnerability, and I'm going to look at the deny list, and this particular one, 3918, is not on the deny list, so I'm going to re-rate it. So it goes from critical down to high. The next vulnerability is critical, and I'm going to compare it against my deny list, and I see that it is on the deny list, and I will not derate it. And then as a result, if we go look at our vulnerability report, we can see here that we've got two critical findings, one from container scanning and one from dependency scanning. There's that 44906 again. That's the one on the deny list, and it has remained critical. And then that other one, 3918, it's high. Now, if we open up this vulnerability record and we go look at the CVE or another link here, we will note that this is going to be critical. Can I not see it in this database? Where should I look this up? Here we go. Perfect. Here we go. Base score of 9.8 or critical, improperly controlled modification of object prototype attributes or prototype pollution. So nearest matters kind of remote code execution level of vulnerability. So in that case, the metadata for that vulnerability still reflects critical, in the links, but I've moved it down to high here. And you can imagine if you wanted to maybe send a notification to your SecOps team, you could, in that same script that I talked about here, this re-rate vuln script, you could hook out to like a seam and add, like a call out there, or if you've got kind of a metrics system, you could fire hook at that and just say, hey, this job for this particular project owned by so-and-so just ran, and it had a couple of critical vulnerabilities, some of which we're going to derate and kind of allow them to progress, and some of which that perhaps you've added on a deny list, we're going to block. And you could use that same type of telemetry to effectively kind of plan how you, sort of work your way and iterate towards a policy that basically just says, all right, we're happy with our posture today, and we're pretty happy with the way that we've got these scanners hooked up. We're going to start blocking all critical findings. While, of course, this isn't quite as elegant as a native product solution, it was one that could be developed fairly quickly. And I'm optimistic that with a little customization, hopefully this paradigm provides a little bit of a creative spark for folks that are grappling with this type of problem to see how it might be solved without the need to change how our product works day one. Hope that was helpful. Thanks for the time.